Hey there, this is going to be a shorter video. I just wanted to quickly go over a certain topic that I encounter a lot and that I've helped some other people out with as well. And this is sort of the issue of codependent reactive values. Now, reactive values is a sort of programming pattern that I discussed in my first from scratch video, where when you update one value, it sends a signal out to other values. It notifies its subscribers that it has changed. You change the value, and then it tells the people who want to know, hey, by the way, someone just changed me. I thought you might want to know. And then, based off of this new information, the subscribers can do whatever they'd like. Now, there are times when you'd want to have two different reactive values depend on each other. They're codependent. Now, what this really means is one guy's value over here is determined from this guy's value, and this guy's value is determined from this guy's value. Now, straight off the bat, this might not make a whole lot of sense, and you'd be right for thinking so, because we're sort of running into an infinite loop over here. And I'm going to go into a bit more of a practical example in a moment, but just a general overview. An idea for why you'd want two codependent reactive values might be when you want to mirror two inputs to each other. You have two different inputs on two different screens, and you want them to share the exact same value. So when one of the inputs change, you want the other input to also change. And when that input changes, you want the other input to also change. And this is something that you might encounter in something like Svelte. Svelte is a, compiler you can call it. It's something that I'm very, very fond of. And it also has this sort of reactive value system. And there are many times when you're creating components or inputs and you're running into this exact sort of problem. And there are two ways to solve it. I'm going to go into exactly what the React parent-child way means, but essentially just to show you a little bit of a demonstration for the example that you might want to use it with if you have a decimal value input and a hexadecimal value input. So I can say 1, 2, 3, 4, 5, and I see this number reflected in the hexadecimal form. And if I edit the hexadecimal form, I can see the decimal representation. So this is a bit of a fluid way to play around with decimal and hexadecimal values. Another general example might be if you want to show the difference between RGB and HSL. That was the example that I ran into this problem with, where I had a color picker that I wanted to show the value represented in many different ways with different sorts of inputs that you can change back and forth. So I'm going to show you most of this code with a reactive library that I made myself. I sort of changed it from a first from scratch video to actually reflect a lot more what Svelte looks like. It does have the power of computeds, which Svelte doesn't super expose to the user. But I'm going to sort of show you how to tackle this problem in many different sorts of ways. So straight off the bat, I'm going to be importing my own little library over here. I'm going to run example 1 with that module, and that's going to, destructure the writable and bind L functions. So you can actually see it working over here. I'm going to run this code just so you're showing it actually works. We're going to see instantly maximum call stack size exceeded at line 18, column 7. This is because, like the problem sort of demonstrated, when this guy changes and affects this guy, and this guy changes and affects this guy, you're running into a sort of infinite loop very, very, very quickly. Now, if you're not careful in certain kinds of environments, this infinite loop is going to crash the page. The page is going to lag, it's never going to end, and you're not going to receive a maximum call stack size if you don't have a call stack. You're just going to receive an infinite loop. Now, the way my thing is built, I do very quickly hit a maximum call stack size exceeded, and so I can't really continue, which is actually very good for me because it ends up sort of pretending that my library works. If you don't see the console and all these errors, it looks like it works perfectly. All right, hello there. It's reflected in the H1. I think this is an H2, but it's reflected in the other input, this other thing over here. All fine and dandy. Just a quick overview for what this actually looks like. We have an HTML file that looks like this with 2 inputs and 2 H2 tags. They're initially empty. We have this bit of code over here, which grabs the 2 inputs. We create 2 writables. Now, this is like a reactor that I created in the first from scratch video. This just means it's a reactive value that I can change later on. It's changeable, which is what we essentially had with our, reactor initially. But instead of changing the .value property, we do .set. is a bit more explicit, and this does help us later on a bit more in some sort of way, which is why I kind of wanted to, use this system instead of the one that I made earlier. Both of these guys, we subscribe them twice. The first subscription changes the H2's text content, so that's why you have this over here reflected the input exactly. And the second subscription over here actually changes the other reactive value. So when we get changed, we're going to change text 2. And when text 2 gets changed, we're going to change text 1. Right? Back and forth. Now, bind L, what this does over here, this is sort of familiar to the bind pattern in Svelte and also maybe in Vue, where we essentially say, whenever this input changes, we add an event listener to it, and we change the store. Whenever the store changes, we change the input. Now, the reason why this specifically is not an infinite loop, and why we can do this regularly and not run into any problems, is because when we change the input's .value property, it does not trigger the input event. So later on in my code, just to show you an example, when I change .value, I think all the way at the end of here, I change the .value of, here we go, input1.value equals value. This does not trigger the input event. So this is fine. This actually doesn't run into an infinite loop. But I'm going to show you some ways to sort of remedy this problem. Again, in my specific example, I run into an error very, very quickly. My code still works because it just stops, running through the call stack. Usually that won't happen and get some very weird, funky results. In my case, luckily I did, but this isn't sort of guaranteed. So the first way to sort of combat this is by, in a certain sense, removing the reactivity entirely. Now, we're still going to have reactive values, but we're going to be using derive. And what this sort of does, and I want to have a little, a little pattern over here. Instead of each reactive value changing the other reactive value, they instead change this over here, big reactive value. This guy changes this guy also changes this guy, and this person sets the two values over here. Right? So this is a different pattern, and this is sort of what we call a one-way data flow, where it's something you might recognize more in frameworks like React, where you don't have really reactivity at all. Instead, the children notify the parent, hey, my data has changed, and the parent then handles passing on the actual state to the children. So in our code over here, what we're doing is, example 2, here we go. We're creating a derived store. Now, what derived store is it takes an original store, and then every single time that store changes, we change ourselves. Right? That's all we're really doing. Now, we can't write to it directly. The only time we can ever write to the store is in this function right over here. That's the only time we're ever able to do this, which means this store only exists as a function of this store. This store doesn't really exist as its own data source. It's not really its own writable thing. It only exists as a function of the parent store, which means that when you can't really change this value. So changing this value doesn't really have any effect. When you mess with the input, so really this arrow isn't really like correct. What we can actually say is we have two separate inputs, one over here and one over here, and these inputs trigger an event to this. This guy triggers an event to this. So we're removing the infinite loop thing entirely because the parent changes these two, but these two don't themselves change the parent. We're not running to any loops anymore. So again, to look over the code more specifically, our derived store is how we create this text1 store as a function of the parent store. Our input changes the parent store. So again, like our model over here, this guy changes the parent store. And then the parent store, again, just has these two be a function of the parent store. And then when, again, these two get subscribed, we change the input's value and we change the H2's value. That's the idea over there. So this is an easy way to, let's run this over here. Let's run the code. Not running into any problems. And this is sort of the way you want to make things. Just as an aside, this is how you should. This is the preferable way to do things. If you're running into a situation where you have two values that depend on each other, ignore reactivity. Remove yourself from that system. The code that I'm writing is sort of pretending like we have a one-way data flow. Because we do. We have a one-way data flow, but we're still using reactive values. The reactive values don't really have as much power as they used to. but we still are dealing with reactive values while having a one-way data flow. So that's sort of what's happening. In example 3, the third example, which is another way to change this problem. If you don't want to have a one-way data flow, if you want to avoid using derive, you still want to have the ability to write to it directly. Because notice that we can't use the bindL function. And this is a very useful function to bind data two ways, that the input changes the store and the store changes the input. Or we can't use that if we're using a derive store. So if we still want to use bindL, if we still want to have this binding ability, we can do something else. Instead, don't change our value. Don't change the value of a thing if its value already exists as that thing. So just to show what this really means, I'm going to run this code. And I'm going to go back to our example over here. So let's say we give this guy a number. So let's say it's the number 7. And this one's also going to be the number, let's say, 6. So we change the red guy to be the number 8. This changes the other guy to be the number 8 as well. This guy changes another one to be the number 8 as well. But wait, it's already the number 8. So don't change it at all. If you're trying to change another reactive value to what it already is, do not trigger a subscription. And this is actually what many frameworks do already. I believe Solid.js does that with its signals. I believe Svelte does that with its writable stores. My code doesn't do that. So I'm kind of showing you how to hand implement that sort of feature. But we just say if the value that we're trying to change it to already exists as its current value, so text2.get, its current value equals the value we're trying to change it to, then do not change it. Because again, there's no point. It already has that same value. So why do that? What's the point over there? So this, again, works pretty well. No real problems over here. Hello there. Now, this does run into its own suite of problems. First of all, you have to do this check every single time. You have to say, okay, if it has this value, don't change it, unless your framework already supports that. But this also runs into problems with precision. Because there are times when you're going to change the other value to be like 8.1, and you change the other value to be, okay, now this one's 8.2, oh, now this one's 8.3, and you go back and forth. Now this could either be a result of the function that you're using, the way your store works, it doesn't change it precisely, or this could be actual behavior that you want, desired behavior. And if that's the case, you're going to run into an infinite loop again, because you're never having the case where you want to change it to exactly what it already is. You always want to increment it in some way. So if that's the case, you're still going to run it into an infinite loop, and you can't really change that. Now, if you're running with RGB to HSL conversions, many times you're going to run into conversions where they're not 100% accurate. You have a decimal value that you have to throw away, and that results in the next conversion not being super accurate. So there are many times where you have this sort of a problem happening. So the final way to actually tackle this problem, I think is the least desirable way, but would actually solve the problem we're encountering. And I'm going to uncomment that one over there. So let's run example 4 and example 3. And let's run this. And again, it works the same way. You can't really see the difference in code in the way I'm typing. But the reason why this is different is we're sending along with the value an origin. Now, this origin tells us what is the thing that changed this value. What is the thing that's requesting that you change your value? So with my input, I'm saying the origin is the input itself. The input says, hey, text1, please change your value. By the way, it's me, input 1, your old friend from high school. That's the person who's trying to ask you to change your value. Input 2 does the same thing. It says, hey, I want to ask you to change your value. By the way, it's input 2. And this doesn't really mean anything. Anybody can send a set request and it will work. The difference is, in the subscription method, we make sure that the origin is not the same thing as the value we're now trying to change. Because again, remember what our problem was. If I changed you and you're changing me, we're just going to go into a cycle. So what we can do is I'm going to change you, but I'm going to say, hey, by the way, the person who's asking you to change your value, it's me. I'm that person. Right? Okay, fine, cool. Thanks for the update. Now I'm going to notify all the people that are subscribed to me. And I notify them one by one, and then finally I get up to this other guy over here. And I see, wait, 1 second. I could notify this guy, but he's the person who notified me. He's the person who triggered this subscription in the first place. So why would I even bother notifying them if they're the person that changed me? So this time, we're not doing an equality check. We're not saying, okay, whether or not their value has changed or not between the last update. We're saying, who's the person that told me to change? Now, this is something that is really, really annoying to hand code if the library doesn't already have support for this. So again, this is, I think, one of the least desirable methods just because of how messy it is. And you're kind of getting into an area where it's dangerous. You're running into a dangerous area. Recursion and this sort of area with an infinite loop in stores is dangerous. You don't want your code to happen like this. I much prefer my code to crash than run into an infinite loop. And we're running to a very scary area because if we forget to do an origin check whenever we set a value, well, we might just be running into an infinite loop over here. But again, if we do an origin check, if we make sure that the person who sent us a request isn't the same person as the store we're trying to change, we can actually remedy this entire problem in the first place. But just to sort of conclude, example 2 with a derived store where we have a one-way data flow is actually the most desirable way to solve this problem. It's a React-like way because React is what I think of when I think of a one-way data flow, and it sort of makes more code, but it's kind of what we want to do. And to show you the implementation with app.svelte over here, we import React-like and svelte-like. So the input is just a regular input, and it shows its value as a title over there, nothing too crazy. React-like, what we're doing is we're not really dealing with reactivity whatsoever. Whenever we change one of these inputs, we run the onInput function, handle decimal, and we change the other one. We do that for both of them. So we're actually not using the bind syntax whatsoever. We're ignoring reactivity and using a one-way data flow and handling the on input for each of our two inputs. Nothing too crazy, but that's sort of the idea over here, where we're sort of handling it specifically, not in a reactive fashion. We're throwing reactivity out of the window while still getting the exact same result. So this isn't really as nice, I think, but it is a way to solve the problem. It is something that you can do in React, and React doesn't suffer from this sort of issue. With Svelte, if you want to do them in a way like example 3, I think it is. Yeah, example 3, you can just use a writable store initially. So this is a bit more boilerplate, but if we create our writable store and we set the value to something that it already is equal to, well, it won't rerun its subscriptions. Svelte is smart enough to say, hey, if you're trying to change me to a value that I already am, I'm not going to update all my subscribers. Because why? They want to be notified that I'm the same value I was beforehand? No, my subscribers would only care if I have changed, if I'm no longer the person I used to be. But clearly, I'm the same exact person, so why notify any of my subscribers? This isn't interesting news. This is not noteworthy. So if you type over here, you're seeing some values, and we're going to notice there's a bit of an interesting thing over here. If I can type 01111 over here, 01411, I cannot type 01 over there. The 0 gets removed instantly. And that's because of the way our system works. We take our number that we typed in over here, in this case it's going to be 01. We take this number over here, we convert that number to an actual number. We take the string value, we convert it to a number, then we turn it into a hexadecimal value. So we change this input over here. We take this hexadecimal value, and we change this input. And when we do that, when we change the original input, we're changing it not to 011 because the value we have doesn't have the leading 0 in it. So we remove the first 0 automatically. So that's, again, a side effect of how equality checks work. And equality checks are not the perfect way to do this because, like I mentioned, we run into precision problems, or many times where we're changing a value more than once. And that's sort of the idea of codependent inputs. I was going to run through a lot of different sort of reactive patterns and ways to solve certain things, but I think this sort of deserves its own episode. And I know I wasn't extraordinarily clear in a lot of my explanations, but I hope this gave somewhat of an explanation for how to change things. And real quick, I do have things commented out over here. This will not work in Svelte. If I comment all this out and uncomment this, I get a cyclical dependency detected. Because again, this doesn't really make any sense. If your decimal relies on hexadecimal and hexadecimal relies on decimal, then neither of them ever even have a value to begin with. This is basically the same thing as doing a derived store. And if they both are derived on each other, well, again, that doesn't really make any sense. What is the first value that they can be derived off of? Over here, we're actually specifically setting its initial value, so this actually works. But yeah, I hope this video was useful to somebody. If it wasn't, so be it, but I hope it helped someone out there with a similar sort of problem that I've ran into in the past.